Hello students, let's go to next topic of our syllabus. In this process, we have to going to learn about thermodynamic processes. Thermodynamic processes in this topic, we have to learn about the classification of thermodynamic processes. There are different type of thermodynamic processes. They get classified into groups according to some conditions. So before going into detail of classification, let's understand. Already we have that part also we have seen. Let's revise it. Thermodynamic processes we have learned. We have seen there are three basic parameters, that is the pressure, volume and temperature. This P, V and T, these are the three basic parameters in thermodynamic processes. Either of this parameter get changed, then the process get changed, and that process has new name, and accordingly the thermodynamic processes are classified into 6 groups that we have to discuss one by one. So here, while discussing that thing, what they have done, while doing at one time, one variable is kept constant, two variables get varied, and accordingly processes get changed. For example, in this case, P is constant, V and T get varied. So this would be the first thermodynamic process. Then V is constant, then what get varied? P and T get varied. This is second thermodynamic process, and so on. So this thing they have done here. So here in the classification, the first classification they have started with this, depending on this, the first classification that name as reversible and irreversible processes. Might be all of you are well known about this reversible. Might be all of you have heard this word reversible in chemistry also. So let's start with this reversible process and irreversible process. As this process has its name, it is reversible process. The process which can move in forward direction as well as in backward direction, similar to initial state, that is said to be a reversible process. One of the best example for this might be all of you are well known about when we heat a water converted into gas, that is nothing but a water vapor. When we condense the water vapor, it again converted into what? It gets converted into water. Again, if you condense the water, it gets converted into ice. So the basic example of this reversible process is nothing but this. So if we heat the ice, suppose we have the ice, if we heat it, if we give the heat to the ice gets converted into water. If we heat the water, then it gets converted to water vapor. So this is the process. It is going left to right. It is going from left to right. If we heat the ice, convert it into water, heat water, convert it into water vapor. Similarly, in this case, if you come in reverse order, so this is forward reaction. If you come in reverse order, if we cool down water vapor, if we cooled it, instead of heat, cooled it. If we cooled it, it gets converted into water. If we cool the water, it gets converted into ice. So the process goes from left to right as well as from right to left. So such a processes which goes in forward as well as reverse direction, they are said to be reversible processes. They can go from ice to water vapor at the same time by providing the heat. If we remove the heat, provide the cooling, suppose, same process get reverse, water vapor to ice, and such a processes are said to be the reversible processes. If you remember in the initial topic we have learned the PV diagram. So I have drawn here PV diagram, pressure versus volume diagram. In this case, in reversible processes, if the system moves from A to B, so this arrow represents as it is moving from A to B in this direction. So that is forward reaction. When we same system come from B to A, so this is the arrow, it is going from B to A. Curve remains same. Path remains same, and that processes comes under this, and that processes are said to be reversible processes. Now let's go to next part, that is irreversible processes. Exactly opposite to reversible processes, the processes are, and that are said to be irreversible. As its name, it is irreversible. The processes which can move in forward direction only, that cannot be reversed, that processes comes under this, they are said to be irreversible process. One of the best example, as they have mentioned in your book, suppose the two bodies are in equilibrium. Suppose we have two bodies, suppose this is body A and this is body B. Both have a different temperature. So suppose this is hot body, this is hot body, this is cold body. When we put both the bodies together in contact with each other, what can occur? After some time, thermal equilibrium get reached. Hot body loses its temperature. At the same time, cold body increases its temperature, absorb the temperature of hot body. After some time, both the body A and B have the same temperature. We can say thermal equilibrium get reached. Okay, this is the process. Now, afterward, it never possible that the body A will reach to its original temperature. It becomes hot then again. Body B becomes cool again. That is not possible because that is an irreversible process. Initially it is hot. Initially it is cold. But after some time, when they come in contact with each other, they becomes the temperature get changes. After some time, maybe 1 hour, 2 hour, both of them have same temperature. Afterward, body A never gain a original hot temperature. At the same time, body B never gain its original cold temperature because that is a past. And this process can't be reversed, and that is the example of irreversible processes as they have mentioned in your book. Apart from this, if you draw the PV diagram for this, the PV diagram for this is nothing but what? It shows as system move from A to B, system move from A to B, this is the first path, this is the first path, forward direction. Okay, forward direction. When the same thing get reverse, it can't follow the same path. It will follow the different path. Let's see. It will follow the different path. B to A, this is path. A to B, this is a curved path. What does it means? The system this system can't get reverse. That is said to be the process can't get reverse. Still, in this case, the process get reverse, but the condition get changed. Path get changed. Path get changed means what? So this process is said to be 100% irreversible. And if we consider this diagram nearby, see the path is same, A to B or B to A, path is same, means the process is 100% reversible. Here the process is not irreversible. Apart from this, what they have mentioned here, a real thermodynamic process will always encounter some losses due to friction or some dissipative forces, and that is nothing but this. This goes from B to A straight line because of some losses due to friction or dissipative forces are there. Apart from this, just they want to know, just they want to discuss the causes of irreversibility. That they have mentioned two causes. The first cause they have mentioned the process such as a free expansion of the gas or explosion of the chemical reaction. In these cases, the system abruptly, quickly change to non-equilibrium state. That is the first cause of irreversibility. Second cause, as they have mentioned, most process along with this they have the frictional forces due to viscosity, due to surfaces, apart from some dissipative forces are there, and that are responsible to make the process irreversible. So these two causes they have mentioned. Apart from the next, they have mentioned the assumption for discussion of thermodynamic processes. Whatever the thermodynamic processes we are going to discuss further, that all thermodynamic processes depends on three basic assumptions that they have given. The first assumption they have mentioned here is what? They have mentioned the first, the thermodynamic processes we are discussing in the further, the system we are considering for thermodynamic processes discussion is said to be, it is nothing but are reversible processes. All thermodynamic processes we will discuss further, they must be reversible and quasi-static process. Quasi-static means what? That are very slow processes. The time taken by them is infinity. So long-term time the process will require. So they are very slow processes. The system therefore is said to be thermodynamic equilibrium due to all changes. Okay, that is said they are in thermodynamic equilibrium. Second, the system involved in all the processes must be contain ideal gas enclosed in a glass cylinder or chamber which has a pulley, frictionless massless pulley attached to it. So that is the second assumption. The gas contained in study of this must be the ideal gas, and that must be contained filled in a closed chamber with a piston and massless wetless pulley. Apart from this, there can be good thermal conductor for adiabatic process, isothermal processes. The walls of container must be walls of container must be good thermal conductor for isothermal process, or can be thermally insulating material wall for adiabatic process. That would be changed. That was done according to process. The third one and the last one assumption, the ideal gas equation is applicable to all systems. Whatever the system we are going to learn here, whatever the process we are going to learn, in all processes, ideal gas equation is applicable. PV equal to nRT. That already we have learned. Now let's go to second system that is said to be isothermal process. So this we have learned reversible and irreversible process. Now let's go to second process, that is said to be isothermal process. So let's start with this isothermal. So this is isothermal process. What exactly occurred in this second isothermal process that we have to learn? So as its name suggests, that is isothermal process. While doing this process, the temperature remains constant. There is no change in temperature. Either it would be constant at some value, or whatever the temperature, it remains same throughout the process. Then the process is said to be isothermal process. Temperature is kept constant, so that is said to be isothermal process. In this isothermal process, as the temperature is constant, we know that if there is no change in temperature, internal energy remains constant. Why it remains constant? Because temperature is constant. So in this isothermal process, internal energy of the system or process always remains constant because temperature is constant. Now what are going to change? The change are, we are going to just PVT, we know. Temperature is constant, so we have the two variables, pressure and volume. So pressure changes and how the volume gets changed, that we have to learn. If you remember, we have learned the Boyle's law. In that Boyle's law, at constant temperature, pressure is inversely proportional to volume, and same study was done under this, and the process is said to be isothermal. So according to isothermal processes, we can write P is inversely proportional to V at T constant. So this is nothing but a Boyle's law, if you remember. Or we can write this as P equal to some constant into 1 by V, or P into V equal to some constant. So this is nothing but a Boyle's law, we know. Now this is the Boyle's law as we know. In this Boyle's law, as temperature is constant, the product of pressure and volume is always constant. Now let us consider here Pi, Vi are initial pressure and volume of the system or process. PF and VF are final pressure and final volume of the processes or system. Then we can write here just simple by using this Pi into Vi equal to PF into VF. It must be constant. So that is nothing but this Boyle's law actually. So Pi Vi equal to PF VF must be equal to constant. What should be the work done now? So we reach to this equation, we reach to this system, this step we reach. Now what should be the work done? We can find out the work done here. As we know, work done can be represented by dW equal to P into dV. But as here volume changed from Vi to Vf, pressure changed from Pi to Pf. So this total work done can be find out by taking integration of this, where volume changed from Vi to Vf. Okay, so we can write this equation. Now we have to go further. So before going into further, this is the equation. Why we have to integration? Because here volume changes from Vi to Vf. We want to find out total work done, and the total work done can be found out by taking the integration of this equation. Now here the question comes as, here it is P dV. So here it is P into dV. Now as we know here, just I will write it here. We know PV equal to what? According to ideal gas equation, it is nRT. We know that we want to find the value of P. So this implies that P equal to nRT divided by V. Put this value of P in this equation and rewrite this. So you can write this as equal to integration from Vi to Vf. What is P? It is nRT divided by V into dV. nRT divided by V into dV. That value we have find out from this ideal gas equation. Now in this case, nRT are constant, so we can take them outside. So same equation can be written as equal to nRT constant. The integration varies from Vi to Vf, 1 divided by V into dV. Those who have mathematics, they are well known about this. What is the integration of 1 by V? It is log of V. So we can write this as equal to nRT into log of V. It varies from Vi to Vf. Now put upper limit minus lower limit. What we can write? You can write this as equal to nRT log of Vf minus log of Vi. And as we know, log m minus n is what? log m divided by n. Mathematical logarithmic formula that we have learned in 11th standard. Use it here. So you can write same as nRT log of Vf divided by Vi. In your book they have used nRT ln of Vf divided by Vi. Ln means it is a log actually, and this is a work done required. So this is a work done we have find out for this isothermal processes. This is the work done that we have find out. Apart from this, as we have find out this work done here, so W I have represented here W work done. So as we have find out work done here, according to first law of thermodynamics, as we know, we can write the equation Q equal to that, if you remember, we can write the equation as Q equal to delta U or U plus W, work done plus internal energy, that will give the amount of energy supplied. But we know here U is constant or U is 0, we can say constant or 0. Why? Because temperature is constant throughout the isothermal process. As temperature is constant, the total energy, internal energy of system is constant. So you can write the amount of energy supplied is totally used to do the work done in isothermal process. Total energy, amount of energy used, total amount of energy supplied is used to do the work done only, because internal energy is constant, we can say. So we can write here Q equal to W. So Q equal to, just we know the value of W is this, just put it here, nRT ln of Vf divided by Vi. So this is the equation for this isothermal process. Apart from this, we can draw here again the PV diagram for isothermal process. What should be the PV diagram for isothermal process? So just draw it here like this. So it is V, here it is P. And here it is a point A. So to move from A to B, suppose, we can write it like this. This is the second point B. And here, these are the pressure changes PF. This should be PI or PF, PI. Here it is VI, VF, that we know. So we can find out in this fashion. This is a PV diagram for isothermal processes, and this is about isothermal process we have learned. Now let's go to next one. That is nothing but the isobaric process. So up till now we have seen the two processes, reversible and irreversible process, isothermal process. Now third one is nothing but what? Isobaric process. Again it is here the third thermodynamic process. What should be that? Isobaric. So I will write it here, isobaric. Isobaric process is the third process, thermodynamic process, that we have to learn. As here the process is said as isobaric process. In this process, the pressure of the system throughout the process, the pressure of the system is constant. So we can say isobaric means what? Pressure remains constant. Pressure remains constant throughout the process. So the process is said to be isobaric process. But remember, here temperature is changing, pressure is constant. So we have a three parameter P, V, T. If this is constant, V and T are changing. As temperature changes, internal energy also change in isobaric process. That's why internal energy changes. So work done get changed and Q also get changed, because internal energy get changed in isobaric process. Initially, temperature is constant, pressure and volume get changed, and as temperature is constant in isothermal process, there is no change in internal energy. That is point to remember. Now here PV diagram they have drawn. I will draw the PV diagram accordingly. So here it is P, here it is V. Only volume is changing, P remains constant, so it is moved from A to B. So this is B, this is A. This pressure remains constant, volume gets changed. So that they have mentioned in PV diagram. Now let's go to the work done. Just find out the work done in this isobaric process. What is the work done? So as we know, work done equal to P into dV. Okay, P into dV. dV is a change in volume. So you can write here this as P Vf final volume minus initial volume. Okay, PV equal to nRT. So we can write this PV equal to nRT. So you can write it nR TF minus TI. and that is said to be final temperature minus initial temperature, and this N and R are constant. So we can write work done equal to Vp into Vf minus Vi equal to Nr into Tf minus Ti. Vi, we have initial and final volume. Ti, Tf are initial and final temperatures here. Now let's go further. From this we can find out change in internal energy of system. Change in internal energy of, suppose this is equation 1, we can say equation 1. Change in internal energy of system can be find out. Now what is the change in internal energy of system? That was given as delta U equal to N into Cv into delta T, or it is said to be delta T. So I have taken as a delta T. So N Cv delta T, this will give the change in delta U. Delta U means internal energy. Now just we can write this as N into Cv means specific heat at constant volume, delta T means final temperature minus initial temperature. Suppose it is equation 2. Suppose it is equation 2. Now according to first law of thermodynamics, we can write here Q equal to delta U plus W. W means it is work done. So just put this value of delta U from this. This is value of delta U. This value of work done. Put it here. You can write N into Cv, Tf minus Ti, that is delta U, plus N into R, Tf minus Ti. In both the equation, Tf minus Ti is common. So you can write this as N into Cv plus Nr in one bracket, and take this Tf minus Ti common. This is to another bracket. Is that clear? Again here, if you take N common, Cv plus R, you can write this N common in the bracket, Cv plus R, Tf minus Ti as it is. Cv plus R, such as that is specific heat at constant volume plus universal constant. It is what? It is specific heat at constant pressure. So you can write this as N into Cp into Tf minus Ti, that is Q equal to. So we get this equation that will give the value of amount of heat supplied to the system. Now here just remember, because Cv plus R is Cp, that we know already, we have put that value. Cv plus R is Cp, that already we know, we have already learned that topic. Now this is nothing but what? Isobaric process. So in isobaric process, as the temperature gets changed, the internal energy also gets changed, and that is a point to remember that already I have told you. Now let's go to next and fourth process, Isochronic process. What exactly isochronic process is, that we have to learn here. So isochronic process is the fourth type of thermodynamic process. So let's start with this. Isochronic process. Isochronic process. Now what exactly isochronic process means, that we have to learn. So isochronic process is a process in which throughout the process of the system, the volume of the system remains constant. So PVT, as we know, as P, V and T. V is constant. V means volume is constant for the process, that is said to be isochronic process. If volume is constant, what is changing? Pressure and temperature is changing. As temperature is changing, again internal energy is changing. So that is nothing but a isochronic process. Again they have drawn the PV diagram. I will try to draw the PV diagram. So here it is P, here it is V. Initially we have drawn it like this because pressure is constant. Now it is exactly vertical. Why so? Because here it is like this. Here it is A, here it is B. Because this volume is constant, pressure is changing. Pressure and time is changing, temperature is changing, volume is constant. So it is vertical exactly. Initially it is horizontal because pressure is constant. So start with this process, isochronic process. What should be the thermodynamic variable changes, that we have to write down. So here we can write Q equal to delta U. Q equal to delta U. Now the question comes, see, initially delta U plus W it should be. W means what? P dV. Okay, dV. There is no change in volume, so work done should be 0. there is no change in volume, work done should be 0 or it will be constant. That's why they have not taken W here, just they have mentioned delta U equal to Q equal to delta U. And as we know, we have just, before we have derived equation delta U equal to N into CV. If you remember, initially we have derived N into CV into delta T. Delta T means TF minus TI, that we can find out. So we can write here, we can write finally Q equal to delta U plus W, that is delta U plus 0, because here there is no change in volume, so it remains 0. So it should be what? Equal to delta U means N into CV into delta T. Same can be written as N into CV into TF minus TI, that is Q equal to. So both are the same equations here, and they are for isochoric process, in which volume remains constant, pressure and temperature get changed. Apart from this, now we have to go for adiabatic process. I think it is better to stop now. We'll see the adiabatic process, cyclic process and free expansion in next topic, and we'll finish the chapter. That would be the last video of this chapter. Now here, before taking a rest, let me tell you what you have to prepare. After finishing everything, they have just mentioned here, just try this, remember this, that topic you have to remember. Now here on page number 91, remember this topic is there for this isothermal process. This topic is very important, that already we have covered, but for topic to be remembered are nothing but on page number 91, you must remember this for isothermal process. On page number 92, remember this come twice, one for isobaric and isochoric process. You must remember that topic, because that are a very important summary of this whole topic whatever I have taught you today. So just go through my video, and after listening my video, try to read the same topic from book. You get better understanding of this. Still, if you have the problem, you can feel free to ask me. And take care, and let's see in the next video. Thank you.